Hello everyone, my name is Won-Kyu Lee. We have prepared the presentation about General Electric gas turbine. We will show how gas turbine works and the different types of gas generators General Electric is offering currently. Gas generator is a combustion engine that produces electric energy using flammable fuels. One thing good about gas generator is that fuels can be almost everything. It can be either liquid or gas or etc. In this slide, it briefly shows the diagram of how conversion works from fuel to mechanical energy to electrical energy. The initial process involves injection of pressured air into the air compressor chamber to create hot air, which later combines with the fuel to create hot gas mixture. And then hot gas starts spinning the turbine blades. Now the energy state here is mechanical, which eventually turns the rod that is connected to the generator. And once the rod, as a result of mechanical energy, starts spinning, the magnet that is wrapped around by copper coil inside the generator creates the magnetic field, and the magnetic field causes electrons to start flowing. And now that state is the electrical state. When the generator creates the electricity, it is about medium voltage, and that is not enough to supply the grid yet. So the energy is sent to the step-up transformer, and now that is delivered to the households. According to the General Electric, they combine often steam turbine to increase the power harvest about 50% more. If you look at the diagram, the hot gas mixture mentioned earlier is used actually to boil the water in steam turbine pipe. Now for the pros and cons of the gas turbine. The advantages of gas turbine is that design is very simple and doesn't require a huge construction comparing to other renewable generators such as wind turbines, hydropowers, or etc. Also, operation and maintenance cost is very cheap as most gas turbine models are usually similar and generalized throughout the models, which means it is very efficient in terms of repairs. The engine startup response time is quite fast, so that there is very little standby time losses, and very little to almost no water is used in this generator. However, it requires separate power source to operate, and the average net out power is medium to low, which requires separate step-up transformer separately so that we can actually send it to the grid with higher power. And net efficient power output is low as well, and the lifespan of the generator is not very long. It is because there is a mechanical tear and wear in the process of filtering air and fuel injection into the engine. Although there are many different types of turbines, we have chosen General Electric models to conduct researches because they are one of the leading companies in this gas turbine field. So their flagship models we have chosen are from highest power output to lowest power output. So they are H-class, the heavy industrial, and F-class, normal or heavy industrial, and B or E-class, the compact industrial that can be a little versatile with other small industries, and cross-fleet and aeroderivatives, which are most efficient and most compact designs. Though ironically, lesser output means more efficiency and more compact. So those H-class are usually less efficient, and aeroderivatives and cross-fleets are mostly efficient. And next, Kevin is going to take over from next slide to talk about high power models. Thank you.
And my name is Kevin Yoon. F-class turbines. We will be focusing on 3 particular models, the 6F, the 7F, and the 9F. The first one of these will be the 6F. It is a heavy-duty combined cycle gas turbine that operates at 50 to 60 hertz with a net output of 135 megawatts and an efficiency of 56.9%. It is capable of operating a wide range of fuels such as natural gas, distillates, and synthetic. It contains an 18-stage compressor that is corrosive resistant to keep the machine as long-lasting as possible. The nice thing is that this turbine has low emission rates, which makes it the perfect application for industrial parks. The other applications that this turbine is able to do is pulp and paper production, as well as aluminum manufacturing. The second version of the F-class we'll be looking at is the 7F model. For this class, we will be talking about the 05 version. This model, the F-class, is cheaper, it's easier to maintain, as well as volatile. It is operable at 60 hertz, single cycle, and is extremely responsive compared to its predecessor. With a start capacity of 243 megawatts, as well as low emissions and grid stability logic, it makes it perfect for the supporting of renewable energy growth. Being able to be more flexible in fuel than the 6F model, it's able to take in more variants of fuel, giving more options and costs as well as availability. It also runs a 14-stage compressor that features a new spec known as the 3D aerodynamic airfoils. This all helps it with its life, its production life, as well as its efficiency. The last of the F-class turbines we'll be looking at is the 9F model. The one we'll be talking about is the 05 version. This model is cost efficient, has cleaner power, and boasts the most advanced out of all the other F-classes. It runs 50 hertz, combined cycle net output of about 500 megawatts, and has an efficiency of over 60%. The best use for this model is for power plants or cycling applications. Compared to its predecessors, it boasts new specs. It has an incredibly fast startup time, which cuts off 20 minutes from before, and has a Mark Vley control system, which monitors the turbine's health and relays information back to the technicians. And it also has a dual fuel system, which reduces excess liquids formed from the turbine itself. The third type of gas turbines we'll be looking at is the H class, most notably the 7HA and the 9HA models. First, we're talking about the 7HA, which operates around 50 to 60 hertz and has a net output of 400 to 1300 megawatts of power. It is a combined cycle that runs at an efficiency of about 64%. Much like the F-class models, these models have low emissions as well as fuel flexibility. Unlike the F-classes, this model was made with a shorter lifespan in mind. Therefore, it was designed to have specs that were quicker to inspect, parts that are easier to repair, as well as maintaining it as long as it can operate. The second H-class model we'll be looking at is the 9HA. This is the world's most efficient combined cycle gas turbine for its application at power plants. It is an air-cooled gas turbine that has improved specs as well as a simpler configuration compared to the 7HA. Depending on the model, for example, the O1 or the O2, it has varying rates of capacity for its application's power generation needs. It boasts extremely fast startup time as well as not requiring a separate cooling system, making it easier to implement into a power plant. It has a very very cost effective due to its fuel to electricity ratio, and the new specs it has over the 7HA is having a 4-stage turbine with 3D aerodynamic hot gas path, a cooling and scaling improvement cooling and scaling improvements, a single crystal and directionally solidation blades, as well as a double wall casing for improved clearance control. This turbine also reduces the need for on-site gas compression as well as a low fuel pressure requirement, making it easier, much simpler to use than the 7HA.
My name's Abdil, and I'm going to be going over the B&D class. So in the first class, we have the 70.03. It has a 60 Hz operation with a net output of 142 megawatts with an efficiency of greater than 52%. Its medium-sized architecture lends itself to flexibility in the plant layout, and it has a fast and low cost, so this addition allows for an increase of power. It features a state-of-the-art fuel handling equipment with a multi-fuel combustion system option and advanced gas path. So this allows it to switch between multiple fuel options while carrying a load. And it also has a robust architecture that supports a wide variety of applications. It includes peaking and cycling with a compact footprint optimized integration in industrial applications. In the B class, we have the 6B.03. It runs at a 50 and a 60 Hz operation with a net output of 68 megawatts with an efficiency of greater than 51.6. It has a 17-stage compressor with inlet guide vanes. This enhances the operational flexibility. It's built for extreme conditions in which it can handle multiple startups and can operate in an island mode. It even has a black start feature where it allows it to operate in a volatile grid environment. It's proven technology used in a wide range, such as simple cycle operations to cogeneration and combined cycle to mechanical drive. It remains a preferred solution for remote installations because of its versatility. GE has unveiled the Crossfleet gas turbine that has completed several outages at 501F power plants, spanning inspection services all over major plant components and systems. It has increased intervals of up to 32,000 hours and 1,250 starts, which creates fewer combustion inspections. It has more output and better efficiency in both simple cycle and combined cycle operations, and improved emissions with lower turndown and fuel flexibility. In the air derivatives, we have the LMS100. The LMS100 has 117 megawatt simple cycle output with a 44% simple cycle efficiency. It is the highest simple cycle efficiency gas turbine in the world, providing 2.8 gigawatts of generation with more than 1,400 megawatt per minute of ramping capability. It also has an 8-minute start to full load and emergency ramp speed of up to 500 megawatts per minute. Its intercooled gas system turbine provides a rapid startup. In aeroderivatives, we also have the LM6000. The turbine is a leader in the 40 megawatt space. It has a 45 to 58 megawatt simple cycle output with a greater than 41% simple cycle efficiency. It has a 5-minute fast start that allows operators to differentiate their dispatch capability, while a simple tool spool design results in overall maintenance costs. Its universal and modular packaging gives the LM6000 a smaller footprint and allows for a faster installation and commissioning. It has applications in combined cycle, simple cycle, industrial cogeneration, and district heating. To conclude, the gas turbine is a very efficient device because of its simple configuration and implementation in power plants and its power applications alike. Having various turbine models allows for a wide variety of applications as the need may arise. We had gone over the gas turbine, the combustion engine, its conversion from gas liquids to mechanical energy to electrical energy, and we process this through the workflow of conversion.